Welcome, everybody, to Dallas Personal Robotics Group Robot Builders Night Virtual for July 7th, 2026. Tonight, we will do our normal roundtable presentations and then open the floor up for discussions. Club business, I've got one item. Moon Day 2026 will take place July 18th. It's coming quick at the Frontiers of Flight Museum. DPRG is looking for volunteers to attend and to show off projects. If you're interested, contact Paul or Mark.
Is there a an update on that, Pat? Since Mark's not going to be there, and I wasn't originally, but now I am. I offered to take over the organizing from Mark. So, is there a list of people who've volunteered anywhere, Mark?
Yeah, I've got a list. Yep.
Mm-hmm. Is it like anywhere that I can see it?
It will be soon. Okay. I'll send it to you. Yeah.
Or you can put it in that spreadsheet. The like DPRG
the
organization spreadsheet that we share has got like a Moon Day.
Yeah,
that'd be awesome if you could plug that in.
I'll do it. I'll do it right now, so don't forget.
Excellent. Okay. Mark or Paul, do you guys have any business to bring up? Okay.
Nope.
Then I guess we'll kick it off with our first presenter. Ray has something to show us tonight. Present.
Okay. I have been working on it's a 3-phase brushless motor platform. I can do it right there. It's 2 hoverboard motors, and they seem to have a number, but it doesn't seem very consistent. The 3-phase brushless motor drivers, they're like, a lot of them say like 5 to 60 volts, and I don't know what the current is on those. There's different currents, pretty high current. You could drive a much bigger motor than those. Anyway, so I tried to close the loop on speed control, and it seems to work pretty good. And I am guessing that I think it's critically damp by the way the waveform looks. And it's got to shrink that. Whoop. Get something else up. Anyway, this I don't know if all hoverboards run on 24 volts. 2 of the ones that I had did, and I have another one that's not a hoverboard brand, that actually runs on 36 volts. And let's see if I can get this to go. Sketch. And okay, got that up and running. Can you see that?
Yes.
Yep.
We can.
What?
Yes, we can.
Oh, okay. Anyway, so the bottom 2 squiggly lines are the number of pulses that you get out of that driver board. And in this case, I'm sampling every 50 milliseconds. So I get like about 12. And so you can see it's kind of bouncing around a little bit up and down. And then these two up here are the PWM values. So it's to get the 12 pulses in 50 milliseconds. It's about 3 miles an hour on, it's like a 6 3/4 inch wheel. And the you see the PWM varies like between 70 and 80. And I can stick a load on one of the wheels just by trying to prevent it from rotating. So the green line goes up to compensate. And I'm still getting, the 12 or so pulses. And here's the other wheel. That should be the, I guess, brown line. Goes up above. So it seems to be holding pretty good. So I was trying to like simulate a step response. So I can, right now I'm at 12, actually edges, not a pulse, but an edge on in the 50 millisecond interval. And I can switch it between that and like 6. And I wanted to see when I switch it back and forth, kind of what the response looked like. So there's 12, there's 6, and back up to 12. So it kind of jumps. And I was thinking that little kind of, impulse and then kind of back down. It's like, kind of looks like the critically damped situation that you would have for waveforms. And that, from control 3, it's supposed to give you the quickest response or the shortest time to get to whatever pulses you said you wanted to get to. Like in my case, it's 12 at this point. So the motors are a little noisy, and I think it's because it's kind of bouncing back and forth between 3 values for the PWM, and each step is like, excuse me, about a little over 5, counts in the PWM. So and the PWM in this case is 0 to 255. Anyway, so that all seems to be working okay. And so just going back and forth, this is, right now it's 12, and that's 6. And the kind of the negative spike there, I think also indicates that it's, yeah, there it is there. Kind of where it rises up and then kind of does one, I don't know what you call that, negative dip, and then settles out and doesn't seem to, keep oscillating back and forth. I think if it did oscillate back and forth, it would be underdamped.
You're talking about where it undershoots there a little bit?
Yeah. Like, right, okay, now it's at the 12, and if I go to 6, see how that kind of swings up and then it changes scale. But like right there, it's kind of goes up and down, 1.
Yeah, your pulse width modulation seems to be going overshooting or undershooting a little bit. But when you look at the bottom with your encoders, the pulses, it seems to be tracking well.
Mm-hmm. Yeah. So, and that was the thing. This hoverboard motors actually have 6 wires that come out, or let's see, 6, actually 9 total. So the 3 phases, A, B, and C. In the there's a bunch of smaller wires, thinner gauge. Those are VCC ground and Hall effects for A, B, and C. And then there's the infamous white wire. What does a white wire do? And according to Copilot, it's another TAC output, and it looks like it's open collector because it just kind of bounces close to ground. And I didn't pull it up to some voltage to see if that's what it was. And the 3-phase brushless motors that come with those, I forget which model. I would just call it a Husqvarna mower. That Paul and group is playing with. That one also has I think that same TAC output, and so this board actually generates a TAC output because you're inputting the Hall effect sensors A, B, and C. So it's basically doing the same thing. Anyway, and I also had, get rid of this, blink, and that bigger. Anyway, like I said, the hoverboard motors, the battery on them is 24 volts, but right now I'm running it at 12 volts, and it seems to have enough torque. I've also played around with it outside, and little forewarning, little disclaimer, not the best video in the world, but kind of gets the point across, I guess. Anyway, so I'm kind of switching back and forth between autonomous mode and RC mode, radio controlled mode. Like I said, it's a little difficult to see that, but let's see if I can get this so it doesn't glare like crazy. Anyway, so that is in I'm in RC mode right there, and it pushes it along. They said that, and I think there I try to let it go into autonomous mode. Yeah, when it picks up in speed, it's actually in autonomous mode. Then I switch it back to turn it around. But it seems to track pretty good. I don't have a compass on it yet, and I wanted it to track a compass heading. So in autonomous mode, I don't know, supposedly the average mowing speed, again, according to Copilot, is like 3 miles an hour. That's a pretty good pace. They said if you go any faster than that, your mower doesn't mow that great because it's, can only cut so much grass as it moves forward. So, anyway, yeah, when it picks up in speed, let's see, is that in autonomous mode? It usually, takes off. Yeah, there it's in autonomous mode. Didn't want to run over the videographer. Wouldn't be nice. So anyway, so seems to work okay. I didn't know if it would, well, if I can run it at 12 volts, I don't have to have, I'm just using lead acid batteries, like a little riding lawnmower. They're the smaller size, I don't know, 1U or something, or I forget what the thing is. But if I can run it on 12 volts and have the speed and torque that I want, that's great. I can eliminate the weight and just the size of the other battery. If I was going to run it on 24 volts. I use those because they're cheap. They're like $30 for, and they don't have an amp hour rating. They do have a cold cranking amps because they're made to start, a lawnmower engine, the riding engine. So, but it seems like, a battery that size, you should, I'm guessing, get at least maybe 10 amp hours out of it. So, because it's a pretty good sized battery, and it seems like that's a pretty good estimate for that size battery, that type battery for amp hour rating. The other motors. Let's see, 2, 4, 6, 8, 10. So that makes sense. 10. Yeah. So I think this one also has the TAC output on it. So if you just had basically a PWM driver, that kind of PWM in and 3-phase brushless, motor driver output, you could hook the TAC input or TAC output to a processor pin and, drive it that way. But those boards do produce a TAC output. So because they're receiving the Hall effect sensor outputs from the motor, and they generate that, I think it's like 48 pulses per revolution or 96 edges, from that. So anyway, that's all I have.
Ray, have you thought of using those 3-phase TAC outputs, the Hall effect outputs, as a TAC?
Well, that board, it takes the Hall effect outputs as inputs, and it actually generates. There's a one line that generates like a TAC output.
Okay, a single TAC output.
Yeah, and so it should be identical to what either those motors or these blade motors actually produce. So a little bit different, but as far as I could tell from that waveform, that kind of looked like, critically damped, where it kind of rises up once and settles down to a value, or in the case from going from a higher level to a lower level, it'll pulse negative and then settle out to one value. But it looked like, actually, when I went to 24 volts, and it's, you can play around with the, well, this was a PI loop, not a PID loop. You can play around with the proportional and the integral coefficients, or whatever you figure out that is. And when I go to 24 volts, it looks like it does oscillate a little bit. So I probably have to lower the P value to get, as far as I know, that's one of the things that can do that. I think lowering the P and the I, but more the P coefficient. So anyway, so that's what I've been up to.
Sounds like we got a robot running autonomously. Gold star for Ray.
Yeah. Gold star. I was going to ask, is that a black star for progress, or is that a gold star? But autonomous running.
I saw a robot running autonomously.
Yeah.
I had already wrote gold star in my notes. So
okay, good.
Just want to confirm.
I like that answer. Yeah.
I mean,
good job.
It's a fair question of whether it needs to be autonomous to earn a gold star, because maybe it's sufficient that it just runs, moves.
Oh yeah. Well, we got to set the bar a little high, so.
I agree.
What's that?
Autonomous motion, that's a gold star.
Yeah, I agree.
Moving in RC mode or working, getting something
Yeah.
working, I think is significant progress, a black star.
Yeah.
Give credit where credit is due. It ran by itself.
Yep. So
That's it.
I'm kind of thinking it'll go over. Well, I don't know. The hoverboard was rated for like 6 miles an hour with a 200-pound person on it. And, an outdoor contest robot should weigh a whole lot less than that. I don't know if I will still be able to get it to go 6 miles an hour and maintain control. That's the other issue. But, I thought about a 4-wheel drive platform with, hoverboard motors on it, as opposed to the other platform that I had. It was 2 DC motors but still 4-wheel drive. It's just the 2 wheels on each side connect with a belt. So
this is a hobby robot, not a lawnmower. What you just showed us.
Oh, well, no, I want to, that's, it's like I've got too many choices, too many things to play around with. So the, what was it, last week or the week before? Can't even remember now. Showed the Husqvarna motors and tires and wheels and, on the back of a mower.
Yeah.
And I've also wanted to, I could make that 4-wheel drive with the 4 DC motors, or I could make this 4-wheel drive with, the scooter motor or hoverboard motors. And so I don't know, the hoverboard motors are pretty torquey. I haven't actually got out and measured it, but at the Goodwill, there was one. I didn't like, the wheels were different. It was a different brand, and I didn't get it, but it did turn on, and it was up kind of on a shelf above a rack of clothes. And basically I could squeeze the switches, because it senses whether you're still on the thing or not, or if you've, fallen off backwards or something. Tilted it forward, and it actually burned a little rubber on the shelf. It's like, whoa, go this thing here. So they're more than powerful. I mean, enough to pull a pretty good sized platform, a small mower, definitely an outdoor, contest robot, but yeah, I got a couple stairs on that one. It's like,
Cool. Fun.
what are you doing? So anyway, so that was all I had.
Well, thanks, Ray.
Yep.
Up next, we got Mike.
Yeah, so basically this is Roby rebuild, and I've been helping Mark and Paul by working on the servo code for the head, pan and tilt, and the eyes, because I took over the Uno in the head, and there's, yeah, so Mark created the tilt is underpowered or something. It's not reliable. The pan is sort of okay. I think it has.
I've got it.
Huh?
I have a fix for the pan too.
Oh, okay. Yeah, that's good, because the seems like there's something wrong with the gear, and sometimes it gets stuck in one spot.
I think what it is it's slipping because it's not adjusted properly, so that they're not meshed properly.
Yeah, it's acting like it's not meshed, because sometimes it works, sometimes it doesn't, and something's loose. So good. So I'm going to attempt to show it on my phone, because moving the computer is hard.
So we have pan and tilt. Then is that the?
Yeah, so the head can go up and down and sideways.
Sideways, yeah.
Yeah. So let me try to get. Oh, I should have done this earlier.
And if something screws up, it just kind of cocks to the side, you know?
Basically, yeah.
Danger, Will Robinson.
All right. So, oh, I need to shut off. Okay, where am I? Okay, looks like it's okay now.
We're looking at you. I'm not sure if you need to turn your camera around.
Yeah, I'm trying to figure out how to use the other camera.
Yeah, it's not obvious on my phone. It takes some poking around.
Oh,
yeah,
that's odd. I would have thought it'd be like push this right there. Oh crap! Sorry, I thought it'd just be. Oh, here it is. Found it. Okay.
Okay.
So right now I have the Arduino unpowered, and the power supply is 20 milliamps, and the head moves very freely. So the steppers are spinning and everything. Then if when I turn the power on, so his eyes move and it goes, and it didn't change yet. So now if I do a command, one thing I can do is let's see, share my screen. Okay. Yeah. So this is a plot of the two stall detects, and so I'm gonna do the center command, which is basically what you can see it on the screen. A C, the center, and it went up, and now it's going sideways to the limit, and it's going back to the middle. And that was a pretty good clean run. You saw the spikes on the plot when it hit the limits.
What
And
do the spikes represent?
the stall detect.
Okay.
So if I do a center again, it tried to go up, but it failed to go up. It sort of really failed that time. Let me recenter the head, sort of, and try it again. Like the tilt motor is just not working well.
Yeah, the tilt motor definitely needs to get replaced.
So the red spike there is the tilt limit, and then the blue spike is the pan limit, stall detect, and it's being done in the driver, in the stepper driver, and it's and I'm running so slow that it's a really crappy detect. Reading the instructions on the stall detect, if you go faster, it works more reliably, and if you're running real slow, it becomes unreliable. And I haven't quite figured out how to make it more reliable. There are some hints about how to do it, but I just haven't figured it out. But
Is it sensing like a spike in current or large jumping current?
I think it's a spike in current or something. I'm not sure what's going on exactly, but it seems like it's measuring current changes, and at slow movements, the current changes aren't as obvious or something.
Right.
And if I look at in the code, there's the stall detect threshold has a value of 0 to 255. And what happens is anything below that value is considered a stall, I think. And So if you set it too high, it's always stalled or yeah. And so I set it. It only works at 0. If I set it to 1, it's much less reliable. If I set it at 2, it never stalls. So it must be opposite, but I'm at the extreme end of 0. I got to set it to 0 on both motors for it to detect stall, and it's not even detecting it that well. Oh, so that is the up and down command, and then I can move the head, or the center command. I can move the head left. I just typed in 6 or 7 lefts, and it moved. And then I'll type in maybe 12 or so rights. That's where it's sticking on something in the gear meshing, is right in the center there. It always happens. Try right again.
Yeah, hopefully with the, I added in a little bit more adjustment in there so we can get a tighter gear mesh.
Yeah, I'm even trying to push it and it's stuck. Now I unstuck it. So, and then try the right again. Yeah, okay, now it's meshed again. So thank you for finding that, because I was going to bring it up and go, something's wrong with the gear. And then you'll notice that the power is 110 milliamps. And it went up because it's applying brakes so the head doesn't move after you've done the stepping. And when I first powered up, there's no braking, so it moves really easy by hand. If I do the commands, the power goes up a little bit. So it's not bad. So and then hold on one second. I was going to drop these off to terminate the new motor, but I'll just bring these in a crimper for Thursday, so we can put new headers on the new motors. So okay. If I take the face off, so I built a shield for the Arduino, and then these are the 2 stepper motors, and then this is the tilt wire to the tilt stepper, and this is the pan wire to the pan stepper here. And that's basically all that's on that board, is those 2 modules. And I put a capacitor on there too, just to try to stabilize the 12 volts a little bit, just as a CYA. So that's my show. And oh yeah, here's the inside here, and Mark was showing a new one. So that's the inside. Oh, so that's my show and tell.
Yeah, so you can see a. So yeah, you can see a difference between the sides of the steppers and there in the new one. So the old ones were NEMA 11. This one's a NEMA 17. So this one has the NEMA 11 can put out about a pound of hold force. This one can put out 5 by itself.
Can you raise it?
Also, yeah, and then I also changed the gearing on it too. Mm-hmm. So it's got a little bit better gearing.
That's a much more manly motor.
Yep.
Yeah.
It's hefty too.
Yeah. Get some mass in the brain. Yeah.
Mike and Mark, you guys have been doing fantastic work on Roby's head. He will think good thoughts about you.
Yes. So Paul, do you want to talk about your head?
Sure.
Correctly?
Sure.
To sort of segue into that.
Yeah. Let me share a window. Okay, so this is hopefully it's showing. on my screen anyway. Yes. So this is a no machine window. So just as a bit of an aside, what I'm trying to make happen, and it sort of was successful once, but then it didn't come up the same way a second time. So still more work to be done, but trying to make it so that the Raspberry Pi's onboard Wi-Fi connects to, in STA mode, to some access point, whatever your DMS or we're at home, wherever you are. And then it has a, also has a little USB dongle Wi-Fi. And Mark, I'm hoping we can mount the Raspberry Pi so that there's enough room for this little antenna, and have that be an access point so that anybody who takes Roby to a show can connect to his access point, start him up, run the demo without need for like serial connections or network connections or whatever. Anyway, that's not what I want to show today. I got a program that detects faces. So I've got no machine logged into the Raspberry Pi here. So this window that I'm sharing is a window on my desktop, but it's the Raspberry Pi's desktop. And if I run the face detector Python script, it will launch up, and I've got a camera, a webcam hooked up to it that is, and so can play with. It's actually detecting. You can see the XY coordinates going by in the terminal window, and it's fairly robust to things like rotation and sideways
Profile.
angle on the face.
Hmm.
So anyway,
Well,
the idea is that, and I'm going to take Mike's Arduino face tracking program, which used the HA Cascade last year, which was, and the HA Cascade was not nearly as reliable or as fast as this thing is, and make it track heads, track faces, track the largest face, using the commands that Mike was just demoing. So the Raspberry Pi sending a serial RRR UUU to move the head around to try and center the largest detected face in the screen. So that way, hopefully, the head will track whoever's closest. It was kind of dodgy with last year's implementation using the HA Cascade, because you really had to look straight at the camera to get face recognition to work. But this uses MediaPipe, which is something that Google produced that is it uses a sort of a general purpose convolutional neural network that's been trained on numerous objects, faces among them, and so and then they've layered a solutions layer on top of that, and so you can call it and ask it to do face detection, in which case it only asks the CNN or recognizes only responds to faces that the CNN detects, but other solutions can look for tables and chairs and cats and dogs and whatnot. But it's really, really fast and is apparently quite optimized for getting the most out of a CPU. So much so that it'll overheat the Raspberry Pi's CPU, and so we got to put a heatsink on it.
Is there a fan on the Raspberry Pi?
No, there's nothing at the moment.
Because
so-
fans work really well. Just Pi 4 fans are about
Okay.
$10.
Yeah, so Mark's got that under control. So
Yeah. Okay.
yeah, we'll be doing that. But
Yeah.
there was a demo to was to show facial recognition running robustly and really fast. I think for the real demo, for the real implementation, we want to slow that down because Roby's head response is not going to respond at that kind of rate, anything like that kind of rate. So I'm thinking maybe 2 frames a second might be about right. And then we'll want to monitor on the Raspberry Pi because people like to see themselves in the camera and see the head track them as they move around and make it a show. But anyway,
hopefully we can get there by the 18th.
Yeah,
Are you
I put
using
parameters into the stepper controller, and like the panning is about, I think, 1.5 seconds to go full range, and with 20 steps, and the tilt was about a little faster, I think 1 second or so, and it had about 10 steps.
oh,
So you can,
maybe 5 frames a second might be a suitable rate.
it could help. Yeah. But 100 or something would be useless. Yeah.
Yeah. There's some experimenting to be done here.
Yeah. But slow is okay too. Yeah.
Yeah.
Yeah, because
Are you using a Pi 4 or Pi 5?
Pi 4.
Okay.
Yeah, it's rocking along on a Pi 4. It's a 4 gigabyte Pi 4, and I looked at its memory utilization, and it's running using about 1 meg, so it's not bad.
Seem to be getting quite good response out of it. Way more than 5 frames a second.
Yeah.
Yeah, when I was running ROS on Pi 4, I had to 4 gig Pi 4. I had to enable swap because it was using too much memory for big things like Colcon. Yeah, for compiling.
Well, Paul, I gave you a black star for that significant progress. If
Thank you.
it would have moved to Servo, it would have been a gold star. Mike, I gave you the same thing, a black star. Significant progress for your guys' work on Roby. That's excellent.
And when we connect the two together, we get gold, right?
Yeah, as soon as you move
If
from
it
Servo
moves itself,
autonomously-
I'm confident we can make it move itself.
Yeah. Yeah.
looking
Yeah,
forward to
last
seeing.
year everything was running on a laptop, and it was still slow as dog. So I'm real impressed that the Pi could be that fast.
That MediaPipe just rocks.
Okay, good stuff. That was the end of our presenters for tonight. So, does anyone have any questions or anything to show? Video? I guess
I
that's
think
it.
so.
It's a quiet night tonight, I guess, guys.
Yeah.
Okay, I guess we are going to call it quits.
All right.
All right.
Oh, Ed is asking, can you send the link for MediaPipe?
Just ask Google. Ask Gemini. It'll tell you all about it. It's really pretty interesting. Gemini.google.com and ask about MediaPipe, and it'll give you its background and what it's intended for and a bit of an overview. It's pretty
You
neat.
said it's integrated into OpenCV.
Yeah. So the script is really only using OpenCV to display the image. and draw the box
Okay.
around the face. It's so the camera goes straight into MediaPipe, and MediaPipe spits out the coordinates of the bounding box, and then the call that receives those coordinates then calls the OpenCV to show the image and draw the box around the face.
Okay.
So really, you're just using OpenCV to do the display for troubleshooting, essentially.
Yeah. Yeah.
So otherwise, you don't need OpenCV running at all. If you're running in essentially in robotic mode, it doesn't need to be spitting out an image for display. So then it'll even be quicker.
Yeah.
But I think you said at Moon Day we want to have a display next to the Roby,
Yeah.
right?
Yeah.
Okay.
Yeah.
Just
But I have been thinking about maybe I need to separate those two functions so that you can run them independently, because some of the time you don't really care about displaying it.
Yeah, I've done that with some OpenCV is have a troubleshoot mode. So if it's in troubleshoot mode, it displays the images on the screen. And if it's not in troubleshoot mode, then it's just processing the data and outputting the locations.
I like that idea. Yeah. Thanks.
I
So
did
everybody has to come to Moon Days to see Roby in person.
if I leave now, I might make it.
All right.
Okay, guys. Thank you very much.
Good seeing
Thank
you
you.
all.
Been
Yeah.
a good night.
See you guys next
Bye.
time.
Night.
Nate.